So today we're talking about variation. Specifically, we're going to talk about what's called direct variation. Typically, you're going to see very mathy terms like you might see y varies directly as x. They have a direct relationship, the y and x values. Let's look at a real world example. Just so you understand the concept. So in this case, the y variable would be the number of gallons of gas varies directly with the x variable, the number of miles driven. So if I were to kind of just sketch out a graph here, this would be miles down here. So you could have 1, 2, 3, 4 miles, etc. And this might be a number of gallons. So if you drive in a car, you might use 1 gallon, 2, 3, etc. So let's say that you go, so just for fun, let's say you go 5. You drive a Hummer or something here. So that would be, say you go 5 miles, and this is 1 gallon and 5 miles here. So at that point right there, if you go 0 miles, by the way, you'll be right here. So think of that as like right there. So this would be kind of a linear line if you're getting 5 miles per gallon, so to speak. Your graph might look something like that, where every time you go 5 more miles, you would have to use another gallon of gas. You might go 10 miles and go 2, use 2 gallons, 15 miles, use 3 gallons, etc. So that kind of a linear line, it kind of implies that you're going at a constant speed, just because if you kind of vary your speed a lot, your mileage will vary. But just for the purposes of this, so that's what's happening is it's a direct relationship. Can you tell that the number of, if you're getting 5 miles per gallon, every time you go 5 miles, you use up 1 gallon of gas. And so it's a very kind of a linear, direct variation. It's even more than linear, it's direct. And so one of the things that distinguishes that is this, it always goes to the origin. So the point 0, 0 will be on every direct variation graph. So it's not just linear. So like this line right here would not be linear. That would be kind of weird, right? Use 0 gallons of gas, but use 2 gallons of gas, but you went 0 miles. It's kind of strange. It doesn't make sense in the context of the problem here. So when two variables are related, and there's a constant ratio there. So that's that constant ratio. So this is the idea. This value right there, K, is called the constant. I know it's a K, but it starts with a C, the word constant. But it's a constant. Don't think of that as a variable. I know it is. Y and X are variables that we could replace with many different values. But K, once we figure it out for each problem, will be a constant. There are a lot of equations in the real world that are kind of set up like that. For example, like C equals pi times diameter. That value pi doesn't change, right? That's our K. Circumference is directly proportional to the diameter, because if you take the diameter and multiply it by 3.14 pi, you always get the circumference, right? So there's a direct relationship there. So the constant in that problem would be pi. That the value pi doesn't change. C and D can be many different things, but for that equation, the variable that K value is constant. So like here's an example of kind of a direct. So if you plot those points 1, 2, 3, 6, 4, 8. And you can see if I were to draw a line there, if I had a straight ruler, you can see it actually goes through the point 0, 0 as well. So it goes through, in fact, you might see the pattern. So do you see the pattern kind of going backwards? Well, this is kind of interesting. We kind of skipped a number there. If we had 2 in there, you might see the pattern better. Let's see what's halfway between 6 and 2. So that might be 4. We're going down by 1s here. We're going down by 2s here. If there was a 0, if we kept the pattern going, this would be 0 as well. The pattern seems to hold true here. So it does go through the point 0, 0. It does look linear there. What's the constant proportionality? Sometimes it helps to look at, like, basically that's what's the slope. If you think about the graph of a linear line. So What's x changing by? We're increasing by 1 every time. What's y increasing by? We're increasing by 2 every time. And so you think about slope. Slope is rise over run, or change in the y value divided by the change in the x value. If y is changing by 2 and x is changing by 1, the slope is 2. And you can see the slope is 2 on that line, right? You go up 2 over 1, up 2 over 1. So the constant of variation in this case is 2. The equation would be y equals 2 times x. So think of that as like the slope or the rate of change there for this particular problem. So the function is just y equals 2x. So the equation is always, like if y varies directly as x, it's y equals kx. So you're trying to find that value. You could have found that just by plugging in. And here's what I mean. Once you figure out, if you say yes, if you looked at the graph, you figured out, hey, this is definitely direct variation. They have the same slope, goes to the point 0, 0. This is a direct variation. You could have plugged into the formula. In other words, take a point like this 1, 2 point. So you could say y is 2. I don't know k yet. We're going to pretend we don't know. And x is 1. And solve, right? So k times 1, just divide by 1. You get k equals 2. So for that problem, k equals 2, and k does equal 2. Then you would plug it into the formula. Again, you want to find out what k is. Plug it in as soon as possible, because now that's our formula. This is the equation of this direct variation relationship here. So is this direct variation or not? So again, look for the change in x values. So it looks like we're going up by 1. That's familiar here. So x values are changing by 1. Interestingly, the y values seem to be changing by 1. So the slope is 1, right? The slope is 1. Maybe k equals 1. What else do we need to check to see if it is, in fact, direct variation? You might want to check, well, what's the y-intercept? Is it 0? So if you went backwards here, like this is 0, if you go back to subtract 1, this would be 3. Well, here's the problem with this graph. It starts at 0, 3, has a slope of 1. It looks something like that. Well, that doesn't start at 0, 0. That's not a direct relationship. So this is not direct variation here. So you can look at the table and just kind of discover from that. Here, again, look for patterns here in the so you could do slope. You can kind of say, like, is the proportion. So like here we're increasing by 1. Here we're decreasing, it looks like, by 7. They kind of skip 4 there. If they put 4 in there, let's see what's halfway between 21 and 35. If you add them up and divide by 2, so that'd be 56. Divided by 2 is 28, so minus 28. So it looks like they're still going down by 7, isn't it? Going down by 7, going down by 7. So that's good. If you kind of kept the pattern going this way, that would be 1, that would be negative 7, that would be 0, that would be 0. I like that it goes through 0, 0. The slope seems to be negative 7. I would say the equation is y equals, the slope is, again, negative 7 divided by the x change, which is 1. So the slope is y equals negative 7 times x. That's the equation of this direct variation. So yes, this is a direct variation. Usually when it says, is it direct variation, the next step would be to actually write down what the direct variation is there. You could find the slope between any 2 points, find it between 2 other points, make sure the slope is negative 7. That's another way to kind of do it. So this one, you have to solve the equations for y. So you want to put it in the formula y equals mx plus b, kind of slope-intercept form. So if you do that, I guess you would have to add 3x to both sides. So I would change that to y equals, I'm going to write the 3x term first. It makes more sense in the context here. And so you can see that the slope is 3, so you might be thinking, oh, k is 3, but what's the problem? The y-intercept is not 0, the y-intercept is 5. So this is not direct variation here. Let's try this one. So we're going to move that over there by subtracting 2/3 x. And so you get y equals negative 2/3 x. The y-intercept essentially is 0, so that's good. The slope is negative 2/3, so negative 2/3 is our k value, right? There's our k value in the graph. Identify, yes, this is definitely direct variation. I'll see one more. So Let's see, to solve this one for y, you might just multiply both sides by the reciprocal there. So multiply by 5/2. Let's see, that'll give you y equals, that'll be, I guess it'd be 50 over 2, which is 25. And so yes, k equals 25. The y-intercept seems to be 0. Yes, that is direct variation. So that's the right equation there. Using proportions to solve. So you might have a problem like this. You can use proportions or the formula. So I really like the formula, but I want you to be able to do both here. So let's just try to do both here. So let's see. So suppose y varies directly as x and y equals 10 when x equals 2. So you could try to set up proportions here. So let's just try it this way. Y varies directly as x, y equals 10 when x equals 2. So depending on where you put these, let's say this is 10 when x equals 2. So 10 is to 2, y is to x in the same way that y is to x. So the y would go on top and the x would go down low. Cross multiply that guy, so you get 60 equals 2y. Divide by 2, you get 30 equals y, which would be the answer in this case. Using a formula to solve. So the formula would just, you start with the formula, y equals kx. Let's assume this is direct variation because it says y varies directly as x. So that's our equation. Plug in what you know, right? This is a given. Y equals 10, okay, 10 equals k times 2. Divide by 2, you get k equals 5. Once you get k, plug it into this equation, right? So my new equation is y equals 5 times x. Now it says, what is y when x equals 6? We'll plug in 6. That would be 5 times 6, which is 30. So y equals 30. Either way, you get the same answer. With this method, you know the constant of proportionality. Sometimes I'll ask you, what's the constant of proportionality and what is y when x equals 6 or something. So I may ask you both things in the same problem. If you're given a graph, I mean, this could happen as well. So you have the point like 6, 2. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2. So you get that. You know it's going to have to go through 0, 0, right? So those are the 2 points kind of given. This has a slope of, you see, y change of 2. So you go up 2, so to speak. You go over 6. So 2, 6. So that's really equal to 1/3. Yeah, that makes sense. Like you go up 1 over 3, up 1 over 3, get to the next point. So that's your k value. It does go through 0, 0. So your equation is y equals 1/3 x. Right? You're just finding the slope of the graph. Let's make that a positive 2 there. So 2/3 would be right here, 2, 3. And so that looks like a slope, if you put 0, 0, the slope of 3 over 2. So m equals 3 over 2. I guess I say m equals 3 over 2, but we could say k equals 3 over 2, right? M is really the slope. It's really the k value of the graph. So y equals 3/2 x is the equation of that line. Again, it does go through 0, 0. So that's good. That's the lesson for today.